Hello everyone. In the last video, we had talked about inductive effect and we had listed the inductive affecting groups. In this video, we'll be talking about the applications or importance of this inductive effect, going one by one. The first application of this is it helps us know the stability. It helps us to know the stability of carbocation. Stability. It explains or let us know the stability of carbocation. So how does it know? See, if we see this as example, CH3 plus, CH3, CH3 plus, CH plus, CH3, CH3, and one more C plus, CH3, CH3, CH3. Now if we see here, this is the carbocation in each case. Now we know that CH3 alone, the CH3 group is a plus I effect group. What does this mean now? This means this CH3 is a donating, or it lessens the positive charge. So here we have one CH3 which will try to lessen the effect of this positive charge or the carbocation. Here we have two such, so it will try to reduce twice the positive, and here we have three CH3 groups, so thrice of this one. So the more stable will be this carbocation, as the three stabilizing groups are present, so the stability will be in this order. Similarly, for other cases as well, if we see the plus I affecting groups which are attached to the cation, and compare their power according to the plus I affecting groups list, then we can know the stability of carbocation. The list of these plus I affecting groups is discussed in previous video. Now the second application is this knowing the stability of carb anion. Now similarly, if we see CH3 minus, CH3, CH2 minus, CH3, CH3 minus, C minus, CH3, CH3, CH3. So now we know that if a group of if this structure is, if it is a carb anion, then it will be stabilized if electrons are withdrawn from it. Okay, electron should be withdrawn from it to gain stability, or it wants to donate the electron so that it itself becomes stable. Hence, when minus I affecting groups are present, then it will be stabilized. But here we can see, as CH3 is a plus I affecting group, it increases the positive, it donates the electrons. So this is doing the reverse of what stability it wants. So this will be the least stable one, as 3 plus I affecting groups are there. If minus I affecting groups would be present in a number of 3, then this would be the most stable. But here the case is reverse. So this is the most stable and this is the least stable. The third application being stability of free radical. Taking the same example, this represents the free radical CH3 CH2 dot CH dot CH3 CH3 C dot CH3 CH3 CH3. So if we see that the free radical is electron deficient, so it needs electrons. So the groups which would be favorable is plus I affecting groups. So more the plus I affecting group, more plus I affecting groups, more stability. So here CH2, in general CH3 is a plus I affecting group. So this has more number of CH3 or more plus I affecting groups, so more stable, more stable, more stable. In general, if we formulate it for carbocation, stability is directly proportional to number of plus I affecting groups is directly proportional to strength of plus I affecting groups. For free radical as well, the carbocation condition is applicable. For carb anion, stability is directly proportional to number of minus I affecting groups and directly proportional to strength of minus I affecting groups. So the questions will be: compare the stability of carbocation, compare the stability of carb anion, and compare the stability of carbon free radical. So by comparing the number, the strength of the plus I or minus I affecting groups respectively, we can make sure, or we can put the carbon free radical, carbocation or carb anion in a particular order as per the question. The next application, the fourth application being, it explains the reactivity of alkyl halides. Okay, how? See, in this one, first we'll make a statement: tertiary alkyl halide is more reactive than secondary, then primary, then the CH3X group. Now why this is? So if a alkyl halide is a tertiary alkyl halide, if it donates electron, then it will be a carbocation. Now the carbocation is stable as it has 3 plus I affecting groups. Now if we see, the secondary carbocation is formed here and it is stabilized by 2 plus I affecting groups. Primary, it is stabilized by 1 plus I affecting groups, and here it is not stabilized by any of the plus I affecting group. hence the stability or the reactivity. As a compound is stable when the compound is reactive when it becomes stable after the reaction. So after the reaction this will become a stable carbocation, hence it is more reactive. In this order it will be followed.